Hello students, my name is Ongdi Tamang and welcome to my channel WithMeEngineering. So today the topic which I'm going to discuss is the instantaneous velocity in a rectangular coordinate. Alright, let's see. Right. See, so now when we discuss about the instantaneous acceleration, the meaning of instantaneous acceleration means it is the rate of change of velocity with respect to time. It means change in velocity with respect to the change in time, right? Okay, the formula for the instantaneous velocity is a vector is equals to, you can see this, right? dv vector divided by dt. As you can see, dv is the change in velocity and dt is your change in time. You can also write this as velocity final minus velocity initial divided by time final minus time initial. So this is the basic formula of your instantaneous acceleration, right? So now let us see in the rectangular coordinate how does the what is the instantaneous acceleration derivation, just a simple derivation for that. So if you see in the rectangular coordinate, let me draw one. See, this is my x-axis and this is my y-axis, right? So in the x and y axis, I will consider one point here and I will consider this point to be as an A, right? So this is my A. Is my any point on the xy coordinate which is placed in a space, right? So now for this case, if I want to, so if I just give the distances of the coordinate of the A, then from the origin from the origin O, let us say this is my position, right? So I will define this position as my p vector, position and p. Okay, so that's very good for the acronym to understand. So this is dotted line and this is my dotted line, right? So let me tell you, this is the x-axis distance and this is my y in your y-axis, right? So now as you can see in this coordinate, in this xy coordinate, this A is my any point on the xy coordinate which is giving me the dimension of my x-axis and my y-axis. My dimensions are given to me, or you can also say this as the x and y are the coordinates, means that this A is at a distance of x from the x-axis and this y is the distance of A in your y-axis, right? I hope you understood this. Okay, now let us see what does this says. Okay, so as I told you, so let me write it down here. What are the names of this? Okay, so here, okay, so A is any point in space, in not space, but you can say x in x y axis A, right? So A is my any point on an xy axis, and now rest of it, my p vector is position vector of A. P is the position vector for A and x is equals to distance of A in x axis and y is equals to distance of A in y axis. All right, I hope this little introduction to this coordinate. You understood? You understood this is my rectangular coordinate, right? And this rectangular coordinate is also called, as in your book, in your textbook, it is also called as a Cartesian sign coordinate, Cartesian coordinates. Okay, Cartesian coordinates or rectangular coordinate, both are same. So it is, this is how we see it. Okay, so now let us see what is the how do we derive the instantaneous velocity. As you can see this P. Okay, so P vector, we can write this P vector as x I cap plus y j cap. So this is my formula. So see, what is my, I'll write it here. Okay, my I vector is equals to unit vector, j cap is my I cap is my unit vector in my x axis, j cap is unit vector in y axis, right? So as you can see here, so now if I differentiate this P, differentiate P with respect to time, and time is my small t. Okay, see, if I do this with respect to time, this is my differentiation of P position vector with respect to time. Position means a distance, right? So position vector, distance with respect to time. If you differentiate this, dx by dt is differentiated, I cap is my direction, and dy divided by dt, this is my j cap, right? So I can also write this position vector with respect to time. I can write this as my velocity. I hope you get this right. This is my velocity. So this is my velocity. Then I can write this v dx divided by, now dx divided by dt I cap plus dy divided by dt j cap, right? So this is my, now this v, now this is my velocity, instantaneous velocity. This is my instantaneous velocity in a rectangular coordinate. Now let us see how do we do that in acceleration, for instantaneous acceleration, right? So as you know, what is my acceleration? As you know, acceleration is my is the rate of change of velocity with respect to time, right? So if I differentiate this velocity with respect to time, I can get my instantaneous acceleration, right? So again, differentiating v vector, instantaneous velocity, with respect to time t, right? So for this, v vector, so now see, v vector divided by dt is equals to, now I'm differentiating this. Okay, so I hope you get this, ddt of this one, okay, so this one, dx divided by dt, correct, I cap, plus differentiating t with respect to this, differentiating with respect to time again. So this will become dy by dt, this is my j cap, right? I guess you understood this. So this is my, finally I get my instantaneous acceleration, which is equals to, I can also write this d square of x divided by dt of whole square, which is my I cap, plus d square of y divided by dt whole square, and this is my j cap. So this is my, finally I got my derivation of instantaneous acceleration. So this is a very simple method to find the instantaneous acceleration. Okay, so this is how we derive instantaneous acceleration equals to d square by d square x divided by d square I cap. I cap, as I told you, it's unit vector in x-axis, and d square y divided by dt square, it's, and j cap is my unit vector in y-axis. So this is how we derive the instantaneous acceleration in rectangular coordinate. So thank you very much. I hope you understood this concept on instantaneous acceleration. So if you want to learn something more about the instantaneous acceleration in polar coordinates and some other mode, then you can comment me and you can just let me know if you want the concept to be clear on that, on those topics also, especially for the instantaneous velocity, instantaneous acceleration. So I would be love to do that if you insist me to, if you want me to, tell me to do this. Okay, thank you very much. Please subscribe my channel. Thank you.